So last two sections we're going to look at this week are 8.3 and 8.4. They're both on the same topic, which is writing complex numbers in trig form. Now, we've been writing complex numbers when we study them like that. A plus bi. A is the real part, b is the imaginary part. And if you want to just do adding and subtracting, that's fine. Okay, that works perfect. We just stick with that. So you got 2 plus 3i. You want to add 8 minus 4i. It's just combining like terms. So as long as I did everything right, that's what you should get. It's when we get into multiplying and dividing these that we can come up with a better way of doing it. Okay? Actually, 4 things: multiplying, dividing, raising to powers, and taking roots. Okay? Especially raising to powers. Okay? And I'll show you why we need a better way than this. That's not going to be good for raising to a power. Maybe if it was just to a power of 2, that'd be okay. But if you wanted to raise it to like a power of 10 or 20, that's not good. So in order to figure out what the new way we're going to do it is, we need to visualize this thing first. A plus bi. And the way we can visualize a plus bi is on what's called the complex plane. The complex plane is just like an x and a y axis, except we don't call it x, we call it the real axis. And we don't call it y, we call it the imaginary axis. So if you can graph a comma b, like just as a regular x, like x and y value, then you can graph this. It's no more difficult at all. Let me show you. So if you had the point 2 plus 3i, and you wanted to graph that on this plane, the real part is 2, the imaginary part is 3. That means go to 2 on the real, go to 3 on the imaginary, and then put a dot. That's how you do it. That's how you graph the point 2 plus 3i. You just can't switch the axes. Real has to be horizontal. Imaginary has to be vertical. Let's try a couple more. How about -4 minus 2i? What's the real part there? Yeah?
-4.
Okay, -4. Then it's down 4. Oh, no, I'm saying left 4. Left 4. And then what about the -2i? Which way are we going to go for that? Yep. Well, it's negative.
Oh, down.
So down.
Sorry.
So left 4, down 2. This is real. That's imaginary. 1, 2, 3, 4, 1, 2. That's that one. How about -2 plus 3i? How would we do that one? Yeah.
Left 2 up 3.
Left 2, up 3. There you go. How about 5i? What would that be? Yeah.
Would that just be up 5?
It would just be up 5. The real part is like 0. Okay, so you're not going left and right. So that would be right there. How about 6?
Right 6.
Right 6, because it has a real part of 6 and an imaginary part of 0. Okay. Any questions on graphing these? Simple, right? The reason why I'm doing it is because when we write a complex number in trig form, we're going to look at these points and we're going to figure something out. Okay. Let's look at the red one. Okay, just going to focus on the red one. So I made a circle that goes right through the red dot. What would you call this distance? Yeah?
Radius?
It's the radius. Yep, it's the radius. Well, now, let's say you wanted to measure from here to there. What would you use to measure that? It's like an amount of rotation. What do we have in trig that would be good for specifying how much something rotates? Anyone have a guess? So looking for something you can use to specify the amount like something turns, how much something rotates. Yeah?
Like revolution?
You could use revolutions, yeah, you could. We don't use revolutions as much, we use something else. Anybody have an idea what we use? Yeah? Radians or degrees, which is both an example of how you measure what? A what? So like if you put a label of degrees on a number, then you know that that number represents an angle, yes. So with this red dot, when we write it in trig form, there's two things we have to figure out. What's the angle of it, which is the amount of rotation, and what's the distance from the origin? Okay, what's the radius? We're going to talk about the radius first. Okay. If you measure the distance from here to here, you're measuring the distance from this red dot to this location. What is that location? Yeah?
Origin.
The origin. Now, this is something you already kind of know from like pre-algebra even. If you measure the distance from a point to the origin, what do you call that? No, don't think about it in terms of a circle. But what do you call it when you measure the distance from a point somewhere to the origin? You know this concept in 1D. It's the same word, except this is in 2D. Yeah? So in 1D, you don't have an origin. What do you have on a number line?
0.
You have the 0. So what do you call it when you measure the distance from something to 0?
Absolute value.
Absolute value. And that's exactly what absolute value is in 2D. It's the distance from your point to the origin. So in order to find the radius of this circle, we have to find the absolute value of that complex number. So it's just the distance from the origin to the point on your circle. Now, how would you figure that radius out? If I put a circle, now it looks like a radius. Yeah, we're going to use the Pythagorean theorem. So the absolute value of a complex number is the real part squared plus the imaginary part squared, and then take the square root. You shouldn't be filling in I when you do any of this. There's no I in here at all. Okay. A is this number, B is this number. The I doesn't even get used. The I is just there to tell you when you graph it, that's the up and down. Okay, that's the vertical. So, any question on how to find the distance from a point to the origin using Pythagorean theorem? All right, so let's try it and see what we get. So I want to find the absolute value of 3 plus 4i. Okay, there's no need to draw it, but if you want to, you can. So that's what I'm trying to find. Okay, so again, think of it like this. Just find the hypotenuse of that triangle. So what's the absolute value of, well, first, tell me what the formula would be, and then we'll simplify it. Yeah?
Square root of a squared plus b squared.
And if you fill in our a and b, what would those be?
Square root of 3 squared plus 4i squared. Or is it just 4 squared?
Just 4. No, there's no I in that at all. Now, what do you get when you do the square root of 3 squared plus 4 squared? Yeah.
25.
Square root of 25.
Yeah. And then it equals 5.
That equals 5. So absolute value is measuring a distance. It should never come out negative. And that's how you find the absolute value of a complex number, which is what we're going to use when we're writing a complex number in trig form. It's one of the 2 things we need to figure out. All right, so there's your radius. That's or hypotenuse, however you want to think of it. All right, so we're not doing that. Okay. So complex numbers in trig form. So I've drawn basically the same diagram we just had on the other page. We have a triangle, just like we did before. This triangle had specific numbers. It had a 3 and a 4. This one doesn't, just an x and a y. So I'm letting x be the real part, and I'm letting y be the imaginary. I'm not using a and b, and that is the letters I used before. But I'm not using them this time because I'm graphing. And I think if I use x, people will be more likely to remember that's the horizontal, and y is the vertical. Okay, so when we write it in trig form, you are not allowed to have an x or a y. Those 2 things have to be replaced with an angle of rotation and a distance from the center that we call the radius. So let's start by finding the sine and the cosine of theta and see if that gives us some formulas we can use to get rid of this x and y. It's kind of like we got rid of the x and y yesterday when we did the law of cosines proof. Okay. I told you you can only have certain things in the formula, and we had some things we had to get rid of. Same idea here. Okay. What's the cosine of theta equal to? Yeah.
Is it x over r?
Yeah, just x over r. Okay, what I'm really more interested in is what x is. Okay, so what is x going to equal based on that formula? Yep.
Radius times the cosine of theta.
Radius times the cosine of theta. And can we do y without figuring it all out from scratch? What would y be? No? Yeah?
Radius sine theta.
Radius sine theta. Okay. Any questions on that? Okay. So now that we have those 2 things, we're going to substitute them in for x and y. Okay, if you're not sure where those are coming from, this isn't going to go very well. So make sure, is there any questions on how we got the r cosine theta, r sine theta?
Yeah.
So when you set up a right triangle, if you want to find the sine of theta, sine is opposite over hypotenuse. So it's y over r. When you solve that for y and get r, and to get r on the other side, you multiply each side by r. The r's cancel, and then you have r sine theta equals y. Okay. All right, so now let's write down what we would have if we change the x and the y to what they're pointing to down below. Once we do that, that's basically the trig form of a complex number. That's it. Just replaces the x and the y with a radius and an angle. Okay, so I've already done that. X turns into r cosine theta, and y turns into r sine theta. Now, in each of those terms, what do they both have in common that you could factor out? Yeah,
Radius.
a radius. If you factor out the radius, what would you have?
Cosine theta plus I sine theta.
Exactly. Cosine theta plus I sine theta. That is how you write the trig form of a complex number. So, just a random example of a complex number in trig form. 2 cosine 12 degrees plus I sine 12 degrees. Excuse me. Thank you. That's an example of a final answer. You don't do anything with that. The question though is, how do you find these two things? How do you find the radius? Well, we kind of just talked about how you find the radius. And then how do you find the angle? How do you figure that number out? Well, let's figure out how we do that. So r is the distance from the origin. And what do we call that again? The distance from the origin is really just the absolute value. So you already got a formula for finding r. Now you just need to figure out the angle. Okay, you need to find, actually this diagram is probably better. Bless you. You need to find this angle right here. And you're going to know the x and the y. So what trig function could you use to figure out this angle if you know the x and the y? Yeah.
Tangent.
Yep. Could use tangent. So the tangent is equal to, and what would go on the other side here?
Y over x.
Y over x. Now that's the formula you're going to use. It doesn't give you the angle by itself on the left. I'd rather have the angle alone. So how are we going to get theta by itself?
Take the inverse tangent.
Yep, take the inverse tangent. So there's a formula for finding our angle. Okay, I'm going to write that down nicely on the next page. I just wanted to explain it with this diagram because I had it right there. So finding your radius, you use Pythagorean theorem. Finding your angle, you need the inverse tangent of y over x. Now, inverse tangent of y over x works half of the time because if we think about inverse tangent, we've studied that before. When you type in something and press inverse tangent on the calculator, you're always going to get an answer between what two numbers? Anyone remember? What two angles? It's negative this and positive this. And it's similar to the angles when you do inverse sine, but without the equal to in the inequality. Yeah?
Negative pi over 2 and positive pi over 2.
Yes. When you do inverse, very good. When you do inverse tangent, your answer is always between negative pi over 2 and positive pi over 2, not equal to, okay, up to. In degrees, that's negative 90 to 90. So think about your diagram. Where's negative 90 on that diagram? Yep,
Straight down.
that's straight down. Where's positive 90? Yeah,
Straight out.
straight up. If inverse tangent is only going to give you an answer between negative 90 and 90, That means it's always going to give you an answer in what two quadrants? Right. So that's why I wrote down this formula only works in quadrants 1 and 4. So what do you do if you have a coordinate that's in quadrant 2 and you need to get the angle? Well, let's draw an example, see if we can figure it out. Okay, but this at least tells you how to do it in 1 and 4. Let's go to quadrant 2. Say I had this triangle right here. And I need to figure out this angle. That's quadrant 2. That's the amount of rotation from the positive x-axis. Well, I'm going to start by trying to figure this out. Right, this side's 3, this side's 5. How would you get this angle right here? Or let's try the formula we already have. What's the formula we're using right now? Yeah?
Inverse tangent of y over x.
Right, let's just try the same formula and see what happens. What's y in this case? 5. Now what's x?
Negative 3.
-3. Right, let's just try inverse tangent y over x and see if it gives us an answer that makes sense. What kind of answers would make sense for quadrant 2? Should be between what two numbers?
90 and 180.
Should be between 90 and 180. So let's try our formula and see what happens. Inverse tangent of 5 divided by -3. Is that between 90 and 180? No. Where's -59?
Is it quadrant 4?
That's in quadrant 4. So using the formula we already had didn't quite give us the right answer. What it gave you is that answer right there. That's not what we're looking for. We're exactly halfway off from where we want to be. This answer is, it's in the, I don't want to say the number I'm looking for, but it's halfway around the circle, and we don't want to be there. So what do you think we could add to that number? And it would move us over there. Yeah? You would add 180. Yep. So that is really 120 degrees. That's the angle. Okay. So the trick is when you're in this quadrant or this quadrant, the calculator is not going to give you answers in those spots. It's going to give you the answer halfway around in the wrong quadrant, or it's going to give you it halfway around in the other quadrant. If you want a quadrant 3 answer, the calculator is going to give you the quadrant 1 answer because it can't give you an answer beyond 90. It's not the way it's programmed to work. It only gives you answers between -90 and 90. So the trick in those two quadrants is to always add 180. Okay, but only in those two quadrants, 2 and 3. If you're working in radians, you could add pi. So this covers how to find your angle in quadrants 1, 2, 3, and 4. Where else could your angle be besides quadrants 1, 2, 3, or 4? Yeah?
Like origin.
Well, it's going to be on a circle somewhere, and the circle has to have a radius to it. So it's going to be on that somewhere. But where could I be besides in a quadrant and still be on that circle? Yeah?
On an axis.
It could be on an axis. Let's say we have this point right there. What's the coordinates of that point? As much as you can tell me. 0 comma something, right? It's 0 comma y. If you try to fill this in right there or here, doesn't matter, either one, what's going to happen? You're what? Why? Right, you can't divide by 0. So these formulas don't work if you have a point that's on an axis like that. So when you are on an axis, you have to memorize the answer. Okay? So on an axis, your answer is either 0, 90, 180, or 270. So 0, 90, 180, 270. And you know you're on an axis if your coordinate has a 0. 0 comma something, something comma 0. All right, so now that completely covers how you find the radius and how you find the angle to change a complex number to trig form. Any questions on that? Now we'll try it. So let's try changing that to trig form. Okay, first, can someone remind me what does trig form look like? What's like the template when you write your final answer? Leah?
R times cosine angle plus I sine angle.
Okay, so that's what you're looking for. These are the two things you need to find. Okay, radius and theta. Let's start with the radius. How do you graph the point -2 plus 2i? That's the first thing we did. Okay.
Left 2, up 2.
Yeah, left 2, up 2. So what's going to be my radius in that triangle using Pythagorean theorem? Yep. Square root of 8, which reduces to 2 square roots of 2. Yep. So we start getting really good at Pythagorean theorem. Okay, so square root of 8, and that reduces to 2 root 2. Okay, I'm halfway done. I got my r. Now I need my angle. That's the angle to right there. What quadrant is this point in? It's in quadrant 2. What's the formula to find your angle when you are in quadrant 2? And let's do it in degrees. Okay, let's do it in degrees. Yep.
180 plus inverse tangent y over x.
180 plus inverse tangent. What's y over x? 2 over -2, which is -1. So that's going to give me 180. Inverse tangent of -1. Does anybody know what that is? It's a nice number. -45. Okay. So what's my angle from the positive x-axis to my point? Yeah, 135. Hopefully you could have reasoned out that was the angle a lot easier than that, because this is a 45, 45, 90 triangle, because it's isosceles. So if that's 45 degrees and it's in quadrant 2, it's got to be 135. But if these numbers were different, like 3 and 7, then you got to go through what we just did, because you're going to get a decimal. All right, so now let's take those and write your final answer. So the final answer is r cosine theta plus I sine theta. And that's how you read your final answer. That's the distance from the point to the origin. That's the absolute value. That's the amount of clockwise rotation from the x-axis. Now, what do you think would happen? Don't do this, but if I took this 2 root 2 and distributed it out to cosine 135 and sine 135, what do you think I would get if I did that? Just like that. Well, does distributing something change it? Like if you have something and you do the distributive property, is it still equivalent to what you started with? Yeah, doing the distributive property doesn't numerically change anything. It just writes what you have in a different way. So this is just a different way of writing what?
Negative 2 plus 2i.
Yeah. This is negative 2 plus 2i. That's just a different way of writing. This is trig form. This is rectangular form. If you distribute that out, you're changing it back to what you started with. So I guess if you wanted to check your answer, you could do that. But normally you don't want to do that. The only time you distribute this out is if maybe I gave you that as a problem and I said rewrite this in rectangular form. Then you would distribute it out and tell me what you get. All right, let's try another one. So it was negative 2 plus 2i. Keep this handy because we're going to come back to it. And let's do 3 plus 5. All right, so that was 4. We'll call that 4a. Let's do 4b. 4b. 3 plus 5. Okay. What's my radius going to be this time? Yeah.
Square root of 34.
Yep, square root of 34. Now, can we simplify that? Let's see. Does 4 go into that? 4 times 8 is 32. 9? No. 16? No. That's as good as you're going to get. So there's your radius. Okay, what's going to be the formula for my angle? Yeah.
Inverse tangent times
Inverse tangent of. Yeah.
5
5 over 3. So you're plugging 5/3 into that function. All right, that's not going to come out nice. So we're going to round that, but we're going to do 3 decimal places. So inverse tangent of 5 over 3, 59.036. Okay, so there's our radius. There's our angle. Okay, what's my final answer going to look like?
r times cosine angle plus I sine angle.
Yeah, and can you fill in our actual values?
The square root of 34 times cosine of 59.036 plus I sine 59.036.
And that's a distributive property. That's why I had to put that extra parenthesis at the end. So that's that. So any questions on how we got either of those two? All right, now, I'm not going to review division. I'm going to review multiplication. So I'm going to do a review of multiplication of complex numbers. Okay, when you divide, normally you have to multiply by the, does anyone remember, it begins with a C? When you divide complex numbers, you're multiplying by the what?
Conjugate.
Yes, the conjugate. Okay, normally you're multiplying by the conjugate. So I'm not going to go into that though. What I want to just look at is multiplying and how I'm going to review that quickly. I'm going to multiply the two numbers together I just had on the other page. So it's going to be a review of multiplication of complex numbers. So let's take -2 plus 2i. So this is the review I just mentioned. And let's multiply by 3 plus 5i. Okay. How do you multiply those together?
Foil.
Foil. All right. So let's foil it. What's -2 times 3? -6. What's -2 times 5i? -10i. All right. What's 2i times 3? Positive 6i. And what's 2i times 5i?
10i squared.
10i squared. Okay, combine like terms. What's -10i plus 6i?
-4i.
-4i. And what is 10i squared?
-10.
That's really -10. There's a lot going on here. This is kind of a pain to have to multiply this way. We're still not even done. Now we got to do -6 minus 10, and what do we get?
-16.
-16 minus 4i. There's your answer. Any question on that? Let's change that to trig form. -16 minus 4i. Okay. And remember, the two that we just multiplied together is the same two that we've already changed to trig form individually. Now we've multiplied them together, and we're going to change it to trig form. And I hope you notice something. We'll see. Okay, let's start with our radius. What's the radius going to be there? Square root, and I don't want to reduce this number. It'll probably reduce, but let's just leave it.
The square root of 272.
Square root of 272. Just leave it. Okay, and my angle. What quadrant is -16 minus 4i in?
3.
3. What's your formula to find theta if you're in quadrant 3?
180 plus inverse tangent of y over x.
Inverse tangent of y over x. Well, the y is negative, the x is negative, so they're both going to cancel. So it's really just going to be the inverse tangent of 4/16, which is just 1/4. All right, let's see what we got. So inverse tangent of 0.25 plus 180. We get an angle of 194.036. Okay, now what I want to do is I want to copy down the two answers we had before. I want to write this answer down and see if you can see a connection between them. Okay, so the product is square root 272 cosine 194 036 by sine 036. And the two things that we multiplied together to get that, those were the factors. Factor 1, factor 2. Now, those are what the factors were when they were written in rectangular form. I want to write them down in trig form. 2 root 2 cosine 135. 2 root 2 cosine 135. And the other one is square root 34, 59.036. What did I say? 34. Okay. Any questions with what I wrote? So we know that if you multiply this times that, that's the answer in rectangular form. That's the answer in polar form. I want to skip the rectangular form. I want to jump to, is there a way we could just take this one, which was already in trig form, this one, which was already in trig form, and just multiply these two together directly, without doing this stuff in rectangular form first, getting the I squared, dealing with all that, and then changing it to trig form after. Does anyone think they see a way or see something about how you can combine these two together and get the answer that's above directly? Does anybody see anything? Yeah?
The radius is multiplied together.
Yes. Okay. If you multiply these radii together, remember, to make it simpler, what was 2 root 2 before we reduced it? It was the square root of 8. Take the square root of 8 times the square root of 30. Square root of 8 times the square root of 34. Or, I don't want it to show it to me that way. Just do 8 times 34. It's 272. That's exactly what that number is right there, 272. So if you multiply these two together, you get that number. What could you do with these two to get that number? Add them, exactly. So if I have two numbers, I'm going to make up nice ones without decimals. 3 cosine 10 plus I sine 10. And let's do 5 cosine 15 plus I sine 15. If these are the two things you want to multiply together, and you don't want to go through all the foiling, the I squared, and all that stuff, all you have to do to multiply these two together is 3 times 5, and then add the angles up. So that's a new way to multiply two complex numbers together without any of the I squared. It's a much easier calculation. You just have to multiply two things and add two things, and you automatically get the right answer. Now, what if I had something like, say I had a complex number 20 cosine 40 by sine 40, and 5 cosine 10 by sine 10. Well, if I want to multiply them, it would, well, you tell me. If I multiply these together, what would my new radius be? 100, and my new angle? 50, done. No foiling, no I squared, it all disappears. Now, I didn't show you this yet. What do you think my radius would be if I divided them?
4.
Yep, radius would be 4. And what do you think my angle would be?
30.
30. Yep. Now, normally when you divide, if you were going to do this out, you would have to find the conjugate, multiply top and bottom by the conjugate, do the foiling, change the I squareds, combine like terms. There's a lot of steps. To divide complex numbers in trig form, there's hardly any steps at all. Divide the two radii, subtract the two angles. I'll write that down in a nice formula. Okay. So if you have two things and you want to multiply them together, take the two numbers in front, multiply them. Take the two angles that they give you, add them. If you want to divide, take the two radii they give you and divide them. Take the two angles they give you and subtract them. Now, this trick only is really worth doing if the numbers they already give you are in trig form. If you gave me this as a problem, and you said to multiply together, I'm just going to FOIL it the way it is. It's going to take me longer to change this to trig form, change this to trig form, and then use this trick to do it, than it would be to just FOIL. So this trick is really only efficient if the problem is already in trig form. If not, then do it the old way. And of course, the second radius could never be 0. If it was, you'd be dividing by 0. I think that's the one we already did. Actually, I don't know. I'm just going to make up something different. Okay, I'm going to make up two things, but I'm going to put them in trig form for you already. I'm not going to have you go through these steps where you have to find the r and find the theta. In the homework, there'll be some that you do have to do that. But we did 3 of them, so hopefully that helps. All right, let's pick a radius. 15 cosine 10 I sine 10. I just made those numbers up. And let's do 5 cosine 30 I sine 30. Okay, something's going to happen here that we need to be careful of if this happens. And this will, I think, be our last. Yeah, this will be our last one. All right, let's multiply them together. When you multiply those together, what's your new radius? 75. And what is your new angle? 40. Does everybody agree with that? Okay. So nothing special. Okay, let's divide them. What's your new radius when you divide?
3.
Okay, radius is 3. What about your new angle? Yeah?
Is it 340?
Well, don't go too far ahead. Yes, it could be. But can you tell me what you were thinking before you got there?
-1.
Yes, negative 20. Now, on the test, if I don't say anything, that's fine. That's a good answer. But if I say to rewrite it with positive angles, you can't leave the negative 20. So there's two ways to fix it. Corbin, how did you fix it? That was one way.
I just subtracted 360.
Yeah. Okay, if you add 360 to that, which is really 360 minus 20, you get 340. So that is one way to fix it. The only thing I don't like about fixing it that way is it tends to make your angle very big. It makes it 340. We don't mind big angles, and that's fine. But there is another way to fix it. And we talked about this when we did sum and difference identities. It was something we used in that section. When you have a negative inside of a cosine function, does anyone remember what I said you could do with that negative? Yeah?
Can you bring it like before the cosine?
Not for this one. What's the difference between the cosine of 20 and the cosine of negative 20? What? It's the same thing. Cosine is symmetrical over the y-axis. That means if you reflect it horizontally by putting a negative does nothing. So when you have a negative with a cosine function, you can just get rid of it. You don't need it. Okay, so that works for cosine. Can't do the same thing for sine. Sine is not symmetrical. If you flip it horizontally, you don't get the same thing. So what can we do with the negative that's in the sine argument? You want to remember?
Can you put it on the outside?
You can put it on the outside. If you don't remember that, if you Google even odd identities, that's what these are. Okay, even odd identities. So you can put the negative out in front. So if you put this out in front, what would it become? Yep.
Minus I sine.
Yes. So there's two different ways to fix an angle if it's negative, and they say don't put negatives in your answer. I would accept either way. Okay, so any question on the multiplying or dividing using those two formulas? All right. So if I had this, what does that mean? How do you read that? Yeah?
3 plus 2i, or, yeah, 3 plus 2i to the 20th power.
To the 20th power. Now, 3 plus 2i to the 20th power means to write 3 plus 2i 20 times, and then you'd have to FOIL all that together. Well, it's not really doable. I mean, if you think that's doable, then okay, you can do that. Right? You're not doing that by hand. So if I have a problem like that, or I have a problem like that, I can do it just as fast as long as I don't use rectangular form and I use trig form. So tomorrow we're going to see a quick way of taking any number and raising it to a power. And then the reverse of a power is a root. Okay. So we're going to look at powers and roots tomorrow, but using trig form because it's more efficient, way more efficient than rectangular form. So that'll be tomorrow. Okay, so there was a question in the last class I didn't take out. So let me just double check. Okay, so 1, that's fine. 2, 3, 5 is okay. 8. Maybe there wasn't. Oh, 47. So if you see anyone in the other class, you can tell them to skip 47.
Where you at last?